Hello, this is Professor Kim Nelson with the Jewelry Design Department at FIT. Another tutorial in our series for the bypass ring project. Class, I'm going to finish correcting the mistakes I'd found in the finished model. Left off with the last tutorial right here, beefing up this connection. Now I need to smooth out what's happening here on the shoulder. The simplest way to handle a problem like this one is to simply cut out the surfaces that are offending you, which is this area right here. If you're going to lop that out and resurface it in a smoother way, a couple of principles come into play. You've got to know where you want the parameters to be. I don't want to mess with the bottom of the shank here. I think this is working just fine. And I can't cut above here because I need this connection where these surfaces come together in a smooth way. I have to have that. Okay, so I will cut reasonably close to this. The next challenge I'm going to face is how to orient a cutting plane to slice that surface. I could do a cutting plane from the front, which will be a good start. I'll start there. It's not where I'll end up, but I'll start there. So, actually I'll just start with a curve so I can see it more directly. Start my line at the center and then just pull it straight out. And now, actually it would have been smarter to just do this, the cutting plane, because this can be more visible. So cutting plane, same principle, starting from 0. And I'll just put it anywhere. Anywhere is fine. Okay, so there's my cutting plane. It actually ended up not far from where I want it to be. Going to rotate it back down a little bit. Rotate from 0 in the front C-plane. And just a bit. Okay, the problem is, first off, it cuts all the way through my ring, which is what a good cutting plane does, but it's not what I need. So I'm going to extract an isocurve somewhere in that area, trim off the back of this. So I have a surface that's only going to cut through what I want it to cut through. The other problem I'm facing is that it's at a strange angle to the piece I want to cut. It's nice and perpendicular to the C-plane, which is what a cutting plane is supposed to do. But this bypass ring is twisting in three-dimensional space, and that creates a really odd intersection, which I am not going to want to keep. So I can see better what I'm doing, I'm going to lop off the top of this surface reasonably close to my part so I can easily see what I'm doing. I'm going to rotate this 3D. Okay. To rotate it 3D, I need to have an axis. You right-click on the Rotate button. It's going to ask for an axis. I'm going to use the midpoint on this surface. And you know what? It'll be easier for me, actually. If I move this surface, I'll just slide it along its own edge so it moves straight, so that the middle of the surface lines up approximately in the cleft of my seam there between these two branches of my shank. And now I will do my rotate 3D using midpoint on the surface for the beginning of my axis and the end of my rotation axis. And now I can rotate this surface along that axis. And I'm going to rotate it until it makes a nice agreeable angle with my shank. Like so. And this is what I'm going to use to lop this section out. So, first thing I'm going to do is extract these surfaces at the bottom. Copy equals no. Join those back together. So, I have one piece here. I'm going to split this off. So I'm going to split with my plane. hide the plane for now. Put that on a different layer as well. So these are my three portions. My original shank, the bottom piece of the shank that I'm going to be careful to preserve, and the piece that I'm going to resurface. Okay? There is something interesting going on here that does not make sense to me. Before I split this, there wasn't a surfacing flaw. Once I split it, a flaw showed up. See that hole? That means Rhino is having a very difficult time with the math right here. Now, I could fight that if it was worth it to me, but it isn't worth it to me. So I'm going to offset this surface. Oh, minus half a millimeter. That's a little too far, I think. Minus 0.3. That's good. I'm going to try splitting it from here and see if that doesn't relieve. Yeah, see, that doesn't give me that strange artifact. And that's worth it to me, to move that a little bit so I don't get any mathematical issues there. Hide that. Okay. The rule that I have to understand when I'm going to surface from one point to another, and one end is simple and the other end is complex, like I have here. This is a very simple piece of surfacing. This is a very sophisticated. It is that the more sophisticated surface rules, this is the one that's going to dominate. As many surfaces as there are here, I am going to have in here. I can't come up with fewer surfaces and hope for them to blend smoothly. I've got to have this many surfaces. So my first task, as it were, is going to be, I'm going to go ahead and put these curves in storage because they are important. I used them in our last video. I'm going to start creating my rails. I start with my rails. Now I need a rail along the top of this surface. That's going to be easy to get. And that actually looks acceptable to me. I don't think I really need to change what Rhino came up with there. I think that's fine. I have the same very simple solution over here. And once again, I'm happy with what Rhino came up with. Those were the easy ones. The rest of them are not so easy. I'm going to change the color of this into something that is easier to be seen. Like the light blue. Be easier to plot where these surfaces are coming from. I need to have a surface here where this edge is split. So, easiest way to get that is going to be to extend a curve from arc to point. The problem I'm going to have is the orientation of these two surfaces. So I'm going to check and see what I get. Extend by arc to point. Grab the edge of this. Pull it down, and using near snap, grab the end of this edge of this surface. This is a method you'll see me use a lot when I'm modeling. To come in here and do an arc by point to see where it naturally wants to go to be smooth. It wants to go to there to be smooth, and that is not great. That's not what I want. I want something that comes more straight down. To get that, I'm going to have to extract an iso curve. Toggle, T-enter, and snap, so that it comes to the same edge. But it comes from a different direction. Now I'm not dictated by the orientation of this surface, and I can just pull it from the iso curve. And this iso curve will mark the edge of the surface, and this is what I need to have. I need to have two edges. So that should be fine. extend curve by arc to point, near snap again. See where Rhino wants that to go comfortably. Okay. I'm going to do the same thing from this one. And in this case, the orientation of this surface actually agrees with the orientation of the surface next to it, so I don't need to pull an isocurve. This will be the best solution, the edge of that surface. So extend by arc to point. I want to be aware of the fact that I'm having a surface here at the end that will be cut in half. So, okay, this is not acceptable, but I'm sketching. None of these extend by arc to points are going to be the finished curve. I'm sketching. Okay. So the problem would appear to be this curve here. I need this to come over more, somewhere into this area here. I'm going to pull the seam in between the two surfaces. Now see, that seam actually wants to be quite a ways over. Alright, well, what that's telling me, class, is that as much as I dislike this orientation coming off of here, that it's actually going to flow better with the piece. So, I'll accept it moving as far from that edge as I comfortably can. Like so. Okay, so there, I've sketched those in. Now I'm going to make isocurves on the receiving surface, the simple surface, to match those locations. And I don't like that location, so I'm not going to use it. And I don't need to do it here because that's a surface edge. Same thing is true over here. So I can delete those sketched curves and replace them with blend curves. These blend curves, because they're coming off of isocurves on the surface and actual surface edges, are going to preserve smoothness. I do want to be aware of what's going on in the front view because that's part of the issue I'm having. It's the main reason for redoing this. But I think that that is going to be acceptable. I might back off a little bit here so it's not as full. Okay. Going to do the other side. And the same concern here. I don't want it to be too full here. If anything, I want a little more fullness up here. And now this one. This is an isocurve, actually surface edge, so I can just use the surface edge to the receiving isocurve down on the lower surface. And if I have any opportunity to get elevation up here, it's on this section here, and I really don't have a lot. So like I said, the kind of flattening in the front view is just the nature of this design. But the surfacing is going to be prettier, or that's at least my intention. Okay, this seems like it's spread too far. Even though that's what Rhino wanted to do, it seems spread too far to me. So I'm going to sketch in another isocurve about there. delete this and this. And once again, my only chance for elevation, I don't want bulging down here. If anything, I want some elevation up here, and I'm really not going to have much of an opportunity to get that. So, those are my rails. This sketched rail I will delete because it's no longer applicable. I'm going to come in and split the edge of this surface at each one of these junctures. Analyze menu, Edge Tools, Split Edge. You can see right now I have one contiguous edge, split, 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 enter. So now I have multiple small edges that match the edges of these surfaces here. I'm going to run this isocurve, on the receiving end, an isocurve to match that seam. And I'm going to use mid-snap so that it divides that now split edge perfectly in half. And adjustable curve blend. Don't want any of those. I want this one. And here. Pull back on the bulge. Now this is going to recess in. That's part of the design. I don't want it to recess in very quickly. Okay. Alright, and I need to split this edge again so that this one surface edge becomes two. All of these receiving curves can now be deleted. They won't play a part in making our actual surfaces. So, I have my rails. I'm not going to draw sections I don't need. So, if I can get what I want with just the rails and the two ends, I'll do it. So, surface from Curve Network. Got to unlock that. Okay, now I've got a problem. The surface edge is too long. I can split it, but there's no point. Actually, what I'll do is I'll join back together again these two elements. And that joining will actually shorten the edge to this length. And now I can use the bright green to surface with, which is a nicer color than the dark blue. Surface edge, surface rail, curve rail, surface section, surface section. I don't want it to listen to this surface. If it listens to this surface, it's going to create a bulge at the bottom. So on B, I'm going to take it from tangency to position only. The rest I want. Other side the same. And the same thing. This time it happens to be letter D, but I don't want D to listen to the surface. So I can get a nice crisp corner there. So, I have those two. I am now going to do this surface right here. The theory is I want to be able to do as much tangency matching as possible. So if I surface this segment next, then this piece will have tangency on all sides. Match, 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 and match. So, surface from Curve Network. Rail, rail, surface section, edge section. Now this is interesting. It lost all of my data. This is no longer split at all. The reason it did that is because I joined it. When I joined this together, it undid my edge splitting. Older versions of Rhino didn't do that. I don't know why they do that now, but they do. So I'm going to come back in. It's not a big deal, it's just annoying. Split at each one of my rails. And continue surfacing. Edge section, I should be able to have tangency at both ends, which I do. Now I'll do this piece. Edge rail, edge rail, edge section, edge section. I should have tangency on all sides. Should give me a nice smooth effect. Now I'm going to do this piece right here. Rail, rail, edge section, edge section, and this piece. Edge rail, edge rail, edge section, tangency on all sides. Should give me a nice smooth surface there. This is the last piece. Now what's important to remember here is I don't want to match the edge of this surface. I can't. I have a cleft here. This is supposed to be here. I can match tangency everywhere else, but even though I can ask it to listen to this surface, I don't want it to. I want to keep that seam in place. Edge rail. So I'll pick a curve rail here, so Rhino isn't even tempted to listen. Surface section, surface section, edge section. And you can see that that B is left position only, which is important. Turn off my curves, grab this segment, and join it. I'm going to E-map it. And view it independently. What I'm looking for is whether or not I need more cross sections. There's a bit of a sidewall feeling here that I could smooth out, but it doesn't bother me. Here's a little bit of kind of a buckling here, but I believe that that's just picking up on this surface. Okay, I like what I see. Going to join these together and E-map. Yeah, and I've done. And you can see that is a much cleaner resolution than what I had before. I still have that slight dipping in, but if you compare it to this side, you can see we have this big kind of buckling going on here. And that is now gone. There are still traces, because I can't make a match seam here. There's a little bit of a buckle here. I want to look at that. It can be very tempting just to say, I'm done. I don't want to do more. But you've gone to the trouble to fix it. If it needs further work, you do well to do the further work. This needs a little bit more effort. One section, one set of sections. So cutting plane. Starting from 0. Actually, I think straight out to the side is going to be about right. Now, once again, it's not oriented properly to my surface. I'm going to move it over so that this midline of that is roughly in the joint between these two. And I'm going to rotate it, not three-dimensionally this time because it's a flat surface. It's just flat horizontal. So this time I will rotate it, just rotate it 2D, but rotate it around that midpoint. It doesn't really matter. It's going to slice the same way. Honestly, it's a straight plane, but it feels better to me if it's rotated properly. Okay, and actually, yes, I was wrong. It's flat, but we don't want flat. Look how skewed that is. So, okay, so I will 3D rotate it, mid, and rotate it until I have a sensible relationship between the surface and the shank, the plane of the shank. Okay, all I'm going to do now is do a section, intersection command. Red is fine. I'm going to hide this. And I'm going to delete this. Actually, I don't need to delete it all. I'll keep these two. And I think I can keep that one as well. The others are going to be gone. Because you can see what's happening is right here. This is not good. I'm not going to keep that buckling in place. And it may be difficult to fix because I have these three sections that I'm asking it to interact with. So I'm going to explode that section into 7 segments. Take out the 2 crooked ones and join them back together. There is some strangeness how this is coming in to here on both sides. So remember, I keep telling you that Rhino's a drawing program. That drawing is really the biggest concern. Everything else is secondary. Understanding how to approach this is key. I'm going to bring back my little cutting plane and set a C-plane to it so I can do some drawing in location and have the C-plane working on my behalf. There's a curve tool. One of our arcs is arc 3 points. So you've got to get your arc cascade. It's right here. Intersect, because since I did a cross-section, intersection, these will be touching. Intersect, intersect, and then a final intersect in the middle. Okay. So that is the smoothest thing I can get through there. But what you'll see is it's giving me a mound. I don't really want a mound there. I'm going to explode this. Pull that out. Join the others. I'm going to split this curve. I'm going to do a blend. Off of here and onto here. Turn off my object snaps so that I don't over interact there. Okay, that's really wanting to flatten out right there, which I don't want it to do. So instead I'm going to extend curve by arc to point. The beauty of by arc to point is it's giving you what Rhino wants. What in Rhino's mind is a good match. Rhino thinks that's pretty, and I would tend to agree with Rhino. That's quite nice. Problem is it's not going to be smooth with this panel here. Explode that into 2 segments. And blend curve. I can delete that now. Okay, so that's smooth, that blend curve. It's creating a bulge right here that I know I'm going to hate. So I'm going to play with these points until I get something reasonably close to what I had. Maybe a little bulgier, because that's going to be smoother, but not substantially different. What this means right here is that this surface that I decided to keep is no longer valid, which is all right. Remember, I said it again and again, class, that surfacing isn't hard. Drawing's hard. I can recreate surfaces at will. That's not a problem. The drawing is a problem. Okay. Now, the challenge I've created for myself here is that this no longer contacts, and all of your rails and all of your sections have to touch. They don't have to, but if they don't, you get really unpredictable results. I'm going to bring back that plane for just a minute, because I want to get an intersection point. Just do an intersection. That'll tell me exactly where that is now. In fact, I kind of want to keep that surface there. It'll make my life easier. Go ahead and put these on white. I'm going to have to redraw this curve. Simple as that. So, to redraw it, come back and put back in my iso curve off my leading surface here. Throw that curve away. Redraw it with an adjustable blend curve. Not you. You. And you. Now what I'm looking for, class, is for this curve by eye. There's no way to do this mathematically, but by eye to get it to intersect that point as much as I can. I'm going to check and see if I achieved it. No, I didn't. Typing an end bulge command will bring back handlebars. That's too far. And the best way to evaluate this is to keep rotating your camera when you're looking at something in 3D. Okay. Visually that looks good. So, I don't know when that became a group. It shouldn't be a group. I'm going to check and intersect these two. Perfect. I did that by eye, but I got it so close that Rhino reads it as an intersection. That's close enough for me. So this side of that section has been repaired suitably. Okay. I'm going to do the same thing on the other side. Here's my original arc. I think I should turn this off. I'm going to explode this. This is all one piece. I don't know why, but it keeps wanting to group. Okay, so I'm going to do the same thing on this side. Explode this and blend curve. Adjustable blend curve. I'm going to go all the way from here to the center line. It's going to give me something much more hard and mechanical than I really want. Back off a little bit. It would be nice if it came in and touched that rail so I didn't have to redraw the rail, but I know that's not going to happen. Okay. Now this seems like a lot of work, but I want you to remind yourself of something. One carefully drawn section is worth 3 bad ones. So if I have to come in and do this for 3 more sections, it's a lot of work. But doing it just once, to get one really clean section halfway along my surface, is doing what I wanted to do. I'm a little concerned at how hard that corner is. But I think it'll be okay. So, I'm going to redraw that rail. Same way I drew the last one. Extract an isocurve. And snap. Delete my old rail. I'll just do a quick blend curve. Wow, hit the wrong curves, obviously. There. Bring back my plane so I can see it. And I'll control where this hits with end bulge. I can get a quick reference of where it is now, which can be useful. With intersect. Right now it's there. That gives me an idea how far I have to move it. And end bulge. Reason I'm adjusting on the bottom instead of on the top is because I know one of my complaints was the bottom had too much of a thickness or a bulge to it. So if I'm going to take it away from anywhere, I'll take it away from the bottom. That is getting awfully close. Oh, it thought I was done. Okay, that's a pretty credible job. Intersect. Rhino believes me. Cool. Throw away that point and rehide this surface. I can delete that point. Delete all those points. And I have now a good section. Join them together. Actually, I'm going to need separate sections all the way across here, so I actually split it with this curve, which worked just fine. Split this with this curve, which worked just fine, and now I have what I need. And surface again. Rail, rail, edge section, curve section, and this has forgotten where it's been split again. So analyze edge tools, split edge, end, end, end. Surface from curve network. Rail, rail, edge section, curve section, edge section. Good. Edge rail, edge section, curve. Hello? Oh, sorry. Curve section and edge section. Should be tangency all the way around. Okay. Come back over here. Rail, rail, edge section, curve section, edge section. Looks good. And now this one. Edge rail, edge section, curve section, edge section, tangency all around. Nice smooth connection. And remember, we don't keep the smoothness here because that's a seam, a corner, like a cleft. But we do have it here, surface edge. Curve for the rail, edge section, curve section, edge section. Done. Join these together. Don't need those anymore. EMAP. And hopefully yes. See how much cleaner that is. I have this ever so slight seam line, but that's engineered in. I knew that would be there. That's where those two surfaces come together. There's a soft ripple right here. but nothing I'm going to really be concerned about. That is good enough. So, all I need now is to assemble my piece back together again. And before I do that, I'm going to take off these two surfaces, join them to the main body there, because I'm going to need to be able to use this flipped around to patch the other side. Bring back my cutting plane, top C-plane, so I can rotate this accurately. Rotate, copy equals yes, 0, 180 degrees. Solid extract surface. Join those together so they're a separate entity, and use this to trim away this bottom part. And actually, I brought in the wrong cutting plane. I actually want the high one. That was for the cross section. This is for the actual block. So, once again, transform, rotate, 0, 180, and use this to trim. Mirror this over, or not mirror, but rotate with copy option, 0, 180, and join these together. Hide these. And just as a point of interest, before I finish out this video, so we can compare. That's the segment before the repair. This is the segment after. Okay, a marked improvement. All right. This ring is now ready for presets once I join it together. Okay, so that is the completely finished surface ring shank and head. All right, thanks for watching.